So this topic is normal approximation to binomials. Normal approximation to binomial. And for this, I opted to use an SAT test because it has a lot of questions on it, or GRE test. We said the test has 200 questions, not 20. 20 is easy to do. And they are independent. Each question is independent of the other one. Each question has 4 answers. I'm going to do 4 or 5. What's the SAT? Anyone took the SAT recently? 4 answers to the question, or 5? A, B, C, D?
I feel like it's 5.
5? Okay. Daniel said 5. We'll use 5. Usually they try to get you wrong. Each question has 5 answers. And the last assumption, only one correct answer to each question. Let's say this like the math one, you know? Well, everything I wrote there, there's a purpose to it. What I wrote there, I try to make that test fit binomial. Why? Do you have a fixed number of questions? Yes. That's the first step for binomial. Must have a fixed number. And that's n equals 200. What's the second condition beside being fixed? Must be independent. Are these questions independent? Yes, I stated that in the problem. What's the third condition to be binomial? There must be 2 outcomes to each question, or reducible to 2 outcomes. 2 outcomes, or reducible to 2. We call them success and failure. And I'm going to define success as getting the correct answer here. P is the probability of success, which is what? It says only one correct answer to each question. What's the chance of you guessing? If you just didn't study, just went there, guess on it. 1 out of 5, which is 0.2. And what's the probability of failure? Q, which is the probability of failure, and that's how many? 4 out of 5, which is 0.8. Bless you. And I said each question has 5 answers and only one correct answer. And that takes me to criteria 4, which is what? The probability of success must remain the same through the whole test. The probability of guessing the correct answer for each question stayed the same, 1 out of 5. So that test fits the condition for binomial. And now let's say the question for you, what's the probability of you getting at least let's pick some 120 correct answers. at least 120. Well, you know this is binomial, so I have to use n cx times p to the x times q to the n minus x to find the probability for each case. And n in this example is what? 200. Cx, p, which is 0.2 to the x power, and q, which is what? 0.8 to what power? 200 minus x. And I decided to be mean to you because I said for at least 120. That means what? You got to do this, and for x equals what? 120, 121, 122, 123, 199, and 200. Then add all these numbers. What a mean person I am. Because to get it for 120, that's going to be what? 200 C what? 120 times 0.2 to the 120 times 0.8 to what power? 80. 200 minus 120. And the next one is going to be 200 C 121. 0.2 to 121. 0.8 to the 79. And the next one. We're not going to do it, so don't worry about your calculator. You'll be out of your mind to do it that way. You know? See, what is it? 200, 0.2 to the 200, the last one, 0.8 to the power of 0. So you have to go and calculate all these. Or maybe I can use the normal approximation to binomial. I know the problem is binomial, but maybe I can approximate that as a normal problem. So how do we do that? Well, to approximate that, or to use this method, there's few conditions first you must satisfy. And if we don't satisfy them, we can't do it. So the first question, can I use the normal approximation? And it's not, the answer is yes because of convenient. I don't want to do it that many times. Can we use normal approximation? The answer is yes if you can satisfy these two conditions. N times P must be greater than or equal to 5, and N times Q must be greater than or equal to 5, both. If the answer is yes to both, then yes, you can use the approximation. You can use normal approximation. So let's look at this example. N is 200. What was P? P is 1 out of 5. Isn't that 40? Which is much bigger than 5. So the first test is yes. And the second test, 200 times 4 over 5. Is that 160? Which is much bigger than 5. That says yes, we can use approximation. Both these has to be greater than 5 or equal to it. Well, if you're dealing with normal approximation, you need two things from that problem. If you looked at, well, when you get the homework this week, you'll see any problem that says find the probability. It says, for example, women's height are normally, it will say normally distributed, and we give you two things in them. We give you what? The mean and the standard deviation. Well, we don't have the mean or the standard deviation here. So this is step number 1. Can we use the approximation? Yes. Step number 2, we need mu and sigma, or x bar and s if it's sample. We need the average and the standard deviation. Well, for binomial, those are easy to find. What was the average? Isn't that n times p, which is 40? And what's the standard deviation? Isn't that n times p times q? So for that, n is 200. P is what? 0.2. Q is what? 0.8. Take the square root of that number. It's 5.657. So we need the mean and the standard deviation. We got them. Install. Decided to update Microsoft Word now. Okay, go ahead, knock yourself out. Oh no. I can't update because I don't have a supervisor permission. Stupidest thing. Okay. What's step number 3? Now I call them draw the graph in X. What does that mean? Let's draw it in terms of what we know. We're assuming the SAT test score has normal distribution. The average is what? 40. So if you go blindly to that test, you go and flip a coin there, or roll a dice there, and for each question, you should have 40 correct answers on it, out of 200. Standard deviation is what? 5.657. And now what we're asking you to score at least 120. Now here's the problem. Here's the 120, somewhere there. At least, that means 120 or higher. But wait a minute. I'm not going to put 120 here. Because if I graph this using a histogram, remember what a histogram is? It's a bar graph with no space. This is the 120. And this is the 121, and this is the 119. Well, the 120 does not begin at 120, ends at 120. Where does it begin? Halfway between 120 and 119, so it's 119.5. And it ends where? It ends at 120.5. Is the 120 included? For that question, it says at least 120. Does that mean the 120 is included? So this one and everything to the right of that. So I need to do an adjustment of 0.5. Do I add 0.5 to that 120 or subtract in this case? What number I'm going to write there? Am I going to write 120.5 or 119.5? Look at my picture. Since the 120 is included, the 120 begins where? At 119.5. If this is greater than 120, I will go from where? From 120.5 and up. So So that x value has some graphic notes. I'm not going to write 120. I'm going to write 119.5. So here, either add or subtract 0.5. Go ahead.
We always do that?
Yep. When you do this method, one number, the 120 begins at 119.5, ends at 120.5. So it depends if you want to include it or not. If the question says not including that, bigger than that, we use 120.5. If it says including that, we use 119.5. No, not the midpoint. Well, the midpoint between these numbers. Yes, it's called the boundary. That's what you meant? The boundary value. The midpoint will be the 120 right there. So I'm using the boundary for the 120. Begins at 119.5 and ends at 120. I need to include that in my solution. Going to the right, so that would be 119.5. Step number 4 now. So I got to add or subtract 0.5. I did that. 119.5. Convert to z-score now. And the z-score is what? It's x minus mu over sigma. Now your chance of getting 120 on that test, I can tell you, it's almost impossible if you just guess on it. You'll see that. What is x? 119.5 minus, what was the average? 40 divided by the standard deviation sigma, which is what? 5.657. One 119.5 minus the 40 and divide that by 5.657. Oh, forget it. You're doomed. What is your chance of scoring 14 standard deviation above the average? 14. 99.7 is within 3 standard deviation. So now you look at that normal distribution. Use normal distribution to read the graph. So this is the 14.05, and I need to the right of that. You can do 1 minus the area to the left, and if you look at the area to the left, what do you have? Is it 0.9999? Does it say there if you have 3.5 or higher to use 0.9999? It says if the z value is 3.5 or higher, use 0.9999. That's the area to the left. So what's the answer? 0.0001. So you have 0.01%, 1/100th of a percent of getting a score of 120 on that test or higher. We know that if you guess on it, the average is what? 40, right? So what about if I ask you, same question now, the same story here. We know we can use normal approximation to it, but I'm going to change the question. What is the probability that your score will be bigger than 35 and less than 42? You want it bigger than or equal to 35, less than or equal to 42. You know what, let me make it less than, not less than or equal to 42. So just to show you. I want this one to be greater than or equal to 35 and less than 42. Now this is really not bad to do. We can do normal, the binomial and give the exact answer. Actually, that would be a good one to compare. Now, is the 35 included?
Yes.
And where does the 35 starts at?
Would that be 34.5?
Yep, 34.5. Here is the 40 right here. Is the 42 included?
No.
No, so where are we going to stop?
39.5?
What'd you say?
31.
Oh, I'm sorry, 41.
41.5, yes. Because you are not including the 41. So I'm looking for the numbers right there. I need to find the z value for each one. So the z value for this is what? 34.5 minus the 40 divided by the standard deviation 5.657. And the z value for this one, it's 41.5 minus the 40 over what? 5.657. Remember, the z-score always two significant digits. This is negative 0.97. Two decimal places, not two significant digits. The z value for this, .27. So now I gotta graph that in z. One value is negative 0.97, the other value is 0.27, and I need the area between them. So let me go to my table. 0.27. Positive 0.27. This is the 0.2. Let me find the 7. If my fingers don't cross, is it 0.6064?
Yeah.
Let me subtract from it. So I'm looking at the value of 0.27. Let's look at the negative 0.97 and subtract the two numbers. Negative 0.97. This is negative 0.9. Is it 0.1660? You subtract them, 0 from 4, which is what? 4, 6 from 6, 0. 6 from 10 is 4, 1 from 5 is 4. There's a 44% chance that if you walk into that test and guess on it, you will score between 42 questions and 35 correct questions. High probability. Again, notice the name of this method, normal approximation to binomial. It's an approximation. So I'm curious, how far am I off? Because we know this problem is binomial. I could have done this with binomial. Between 35 and 42, that means you score what? 35, 36, 37, 38, 39, 40, and 41. I can find all these answers and add them. So let's see what the correct answer, the exact answer. To see if I'm close to what they're telling me, this approximation. So you could have 35 correct answers. You could have 36, 37, 38, 39, 40, and 41. It says less than 42. It does not say equal to 42. Less than 42, bigger than or equal to 35. And to find the answer to each one of these, I need to use the equation, which is 200 C35 times 0.2 to the power of 35 times 0.8 to 200 minus 35. What's 200 minus 35? Is it 165? And this is 200 C36, 0.2 to the 36, 0.8 to 164. 200 C37, 0.2 to the 37, 0.8 to 163. Oh, 38 times 0.2 to the 38 times 0.8 to 162. That's an 8 in case you can't read it. This is 200 C39. Bless you. 0.2 to the 39. 0.8 to 161. 200 C40. 0.2 to the 40. 0.8 to 160. And the last one, 200 C what? 41. 0.2 to the 41. 0.8 to 159. $200. Where's the math? Math, probability, NCR, 35 times 0.2 to the power of 35 times 0.8 to the power of 165. And the answer to this is 0.0495. I'll use 4 decimal places. The next one, 36, 36, 164. 0.0567. The next one, 7, 0.0628. The next one, 38.0673. Let's look at the 9. Almost there. .0699. Let's do the 40. .0704, and the last one, .41, and I got .0687. And if you add them, that's your answer. And let's see if we add them. Are we close to that approximation? .0495 plus .0567 plus .0628 plus .0673 plus .0699 plus .0704 plus .0687. 4453. 44.53% chance. What did the approximation method gives us? 44.04. So I am at like 4,000th of a value off. Not even 0.5%. Less than 0.5%. Statistics, if you can be within 3%, margin of error plus or minus 3%. So to be within 0.5%, I'll take that any day. And that's how we use the normal approximation to binomial.